All right. So first off, this is the first time we're going through this particular process. So this is a little bit new to me, although I've given presentations on careers in aerospace engineering before. But certainly, if you have any questions, there'll be an opportunity at the end for us to go through and answer some of those. So first, for a little bit of background, so my name is Professor Jamie Jacob. For those of you I don't know, I'm a professor in mechanical and aerospace engineering, and also the director of the Unmanned Systems Research Institute. Uh, I chose this day in particular because this is Nigel Tufnell Day.
If you can see, yeah, the numbers all go to 11. Look, right across the board. 11,
Oh,
11,
and most of
11,
the amps go up to 10.
Exactly.
Does that mean it's louder? Is it any louder?
Well, it's one louder, isn't it? It's not 10. You see, most blokes are going to be playing at 10. You're on 10 here, all the way up, all the way up,
Yeah.
all the way up. You're on 10 on your guitar. Where can you go from there? Where?
I don't know.
Nowhere, exactly. What we do is if we need that extra push over the cliff, you know what we do?
Put it up to 11.
11, exactly. One louder.
Why don't you just make 10 louder and make 10 be the top number and make that a little louder?
These go to 11.
All right, so happy Nigel Tufnell Day. First off, to kind of give you some perspective, right? Everyone's thinking about their careers. Where I thought I was going was pretty different from where I ended up at. So if I go back and look at where I had planned, essentially when I was a sophomore or a junior in aerospace engineering, my plan was to get a bachelor's of science in aerospace engineering with an astrophysics focus. I was actually minor in astrophysics, and then have a career basically in space exploration. And obviously, where I ended up was pretty different. But that's not necessarily a bad thing. There were two things that changed my plan, though, going along the way. First off was undergraduate research experience. So when I was a senior, I was working in a fluids laboratory, and that gave me really good background and experience, and basically turned me on to something new that I wasn't familiar with. And I got really excited about essentially things like wind tunnel research. The second was the job market had a very drastic shift at the particular time that I was graduating. We had the fall of the Berlin Wall and essentially the end of the Cold War, and that changed the landscape in terms of what jobs were actually available when I graduated. And so that steered me towards graduate school, both of those things. And so while I thought I was going to do one thing, I ended up doing something else, and I haven't regretted that. Now, my perspective is obviously going to be pretty limited. My career path, has been very different from a lot of other career paths. So keep that in mind, as we kind of go through this presentation. There are a lot of options out there, and there are a lot of perspectives that I'm not going to be familiar with as we go through and discuss this. So first of all, my background here, since I did end up going to graduate school, provides me with a pretty different path than probably what you're going to have. But it did end up in a very successful career and something that I've been really happy with, particularly because I get to do lots of different things that normally I wouldn't have been able to do. Work in many different fields and different areas, from space to aircraft to autonomous systems, and go to lots of places over the world, and also interact with lots of different people and agencies and industries through a number of different leadership positions, both within the state and across the country. So let's talk a little bit about engineering itself. Presumably, everyone on here is an aerospace engineering major with that double major focus of mechanical and aerospace engineering. Historically, engineering started essentially in the 1700s, and there were really only two fields at the time: military engineering and civil engineering. Eventually, mechanical engineering was born out of those two separate fields of military engineering and civil engineering, and we've had everything else essentially come out of that. Things such as materials, chemical, electrical, agricultural, industrial, and then new fields such as biomedical engineering. Now, the ones that we're focused on are obviously aerospace engineering, and that initially started off with aeronautical engineering, focus being on design, development, flight testing of aircraft. Once spacecraft, particularly rockets and satellites, came into the mix, astronautical engineering was also developed as a specific field. Now, eventually, both of those merged into aerospace engineering. There are some programs that still offer focused degrees in either aeronautical or astronautical engineering, or a combined degree that you're getting a degree in aeronautical and astronautical engineering. However, almost all aerospace engineering degrees are kind of lumped in with this catch-all term that covers both aeronautical and astronautical engineering design topics. Now, there's another piece called systems engineering, which has really fallen out of aerospace engineering or grown out of aerospace engineering. It's more of a catch-all term and is really focused on the systems expertise that you have with aerospace engineering as a whole. And I'll talk a little bit more about that as well. So sometimes you'll hear about systems engineering programs or systems engineering jobs. And as you're looking at career options, you might see that phrase crop up a lot. And that's a really good place for aerospace engineers to look at in terms of different career options. Because really, the systems engineering field, it has grown out of aerospace engineering as a whole. Now, a little bit of history about OSU Aerospace Engineering. Hopefully, everyone knows OSU was founded in 1890, Christmas Day, as an agricultural and mechanical institute under the Morrill Act. So it's a land grant university, really focused on engineering, right? So all A&M universities have that ag and mechanical engineering focus. The first mechanical engineering specific degree was awarded in 1906. Before that, it was a generic engineering degree that came out of it. And aeronautical engineering was offered as an option starting in 1928 in the School of Mechanical Engineering. That was changed to aerospace engineering in 1965. You can see kind of that evolution of like, oh, we now have spacecraft and rockets that are being launched. So NASA was born in the early 60s. So you see this transition to aerospace engineering as an option. And then in 1968, the School of Mechanical Engineering was renamed the School of Mechanical and Aerospace Engineering. Now, I've always been an advocate of changing that to alphabetical order. School of Aerospace and Mechanical Engineering. However, there's no bias whatsoever in that. I just think it's better to have it alphabetically. Now, we're one of the few schools that actually offer a direct path to both AE and ME degrees that allow you to graduate with both diplomas simultaneously just by taking, a specialized track. So that does make OSU pretty unique in that regard. Most schools, even if they have combined aerospace and mechanical programs in one school, will only allow you to get one or the other. And of course, there are other universities that have separate schools or separate departments of aerospace engineering and then mechanical engineering. Now, our focus is on that vehicle and space systems design, whether any type of aircraft or a spacecraft, but also other ground transportation system and then other autonomous systems as well. So it's a pretty broad spectrum of vehicle systems design that we are focused on. Now, the core specialties that we build upon in aerospace engineering are really those things that lead to capabilities in aerodynamics, capabilities in aerospace structures, and then capabilities in aerospace propulsion systems or power plants. Now, all these things are brought together in addition with that stability component to how do you keep one of these vehicles stable in what we call that system design, test, and evaluation piece. And that's really the stuff then that you're doing at the senior level. And that's where the systems engineering focus comes out of, because you have to have all these components working well together, the aerodynamics, the structural piece, the power plant propulsion systems, and the stability of the vehicle to make sure it all works well. And having this work well and be designed in a holistic fashion is really at the root of systems engineering. Being able to think about a system, looking at it from all the different perspectives and figuring out how to balance that. And aerospace engineers are really good at that, and that's why they're often valued as systems engineers. So that way you can, look at a particular problem, whether it's an aerospace vehicle or not, and say, well, what are all the different factors here that I need to balance to make this particular system work well. Now, aerospace engineering disciplines themselves, right, can fall out into any of these types of areas. So you could specialize in things such as aerodynamics and say, hey, I'm going to be an aerodynamics engineer and focus on the aerodynamics of the vehicle, or I'm going to focus on the propulsion side. And typically that's going to be pretty discipline specific, whether you're focusing on, something that's propeller driven vehicle with a recipient engine, a jet powered vehicle using a gas turbine or a rocket. So you'd probably specialize in one or the other rather than having a pretty broad bandwidth that you'd be applying to those specific aircraft, or something like controls. So a good example of this might be, hey, I'm going to go work for an aircraft manufacturer like Boeing. What are you going to be doing? Well, most likely you're going to be working in one of these specific areas. Structures, for example, or working on the control systems that go into the overall aircraft design. Or you go and work at a company like Blue Origin and say, well, I'm going to be working on the rocket propulsion system, or I'm going to be working on the actual orbital mechanics. How do I get this vehicle into orbit? Or you could be working on the materials or manufacturing components. So there are a lot of different areas and subspecialties that you would apply to a particular company, and most likely you're going to be specializing on one or the other, and then working with other team members that are going to have specialties in the adjacent areas to this. Now, the actual career paths in engineering, assuming we're all going to start with the same place, that we graduate with our Bachelor of Science degree in aerospace engineering, you do have a couple of different career options as you move forward. The first of those, obviously, go out, get a job, right? What your parents want you to do. They go out and start making some money. So that's the most obvious option. The other options that you have are going to graduate school, and that's going to be getting a master's or PhD or a master's of engineering, and really just kind of further your education and get some additional specialization. And I'll talk about those in a minute. You also have other options of going to the professional route, which is essentially, hey, I'm going to get an MBA, or I'm going to, become a patent attorney and focus on, aerospace patent law, for example. So that's kind of the third path. But you don't have to think about these as unique separate paths, because they're all intertwined with one another. You can go out and get a job first, then come back and get graduate school, or do that part time, or any of the above. So there's no distinct one path that you have moving forward with your Bachelor of Science degree. Now, assuming you go that job path, right, and eventually, unless you're a professional full-time student, you will end up here in the actual workforce piece. So where might you work at? Well, with aerospace engineers, it's pretty broad. Anything from private industry to federal or state government, nonprofits, or research institutions. So there are a lot of different things in here. And so it's very hard to narrow it down and say, hey, as an aerospace engineer, you're going to go work on airplanes and rockets. It's not that simple. Because aerospace engineers, particularly due to their systems engineering expertise, are pretty widely valued outside the traditional aerospace industry. So you might even think things such as finance. A lot of aerospace engineers actually work in the finance industry on Wall Street, trying to figure out how you take that investment data and turn it into something that you can actually act on, so something actionable. So the expertise that you have in programming, for example, might be used for data analysis. There are a lot of other U.S. government jobs where aerospace engineers are employed at. Things that you wouldn't traditionally think about. You usually say, hey, NASA, maybe Federal Aviation Administration, Department of Defense. But things such as the National Security Agency hires a lot of engineers to be able to work on various projects. The Army Corps of Engineers, another example, right, that you normally wouldn't think of as that direct pathway. A lot of state government options, Department of Transportation, but things such as water resources, working at a state airport, another example. Um, Other nonprofit jobs, particularly for international activities, working for things to help third world countries, improve their quality of living. And then finally, research institutions, working at some advanced research lab. Sandia National Lab is a good example. We have a lot of students that graduate typically with a master's degree, but we have bachelor's and PhD students go there as well that will work at Sandia National Laboratories on a national lab project. The National Security Council in Kansas City, which handles all of the non-nuclear components for nuclear weapons, is another example of that. Now, since I gave you some examples of different fields, there are also lots of different companies, right? And this is pretty broad again. So you can have big companies and small companies, government agencies and, state agencies. So it's hard to kind of pin down one and say, hey, here's a specific company that you're going to work at. Companies such as Boeing, American Airlines, those tend to be really large employers of our students. Bell Helicopter, Flight Safety International, L3, particularly L3 Greenville, Northrop Grumman, Textron, Pratt and Whitney. Those are also large employers of our students once they graduate. But it's really diverse, across the entire spectrum. And some of these are pretty obvious. You might think, hey, Boeing, they build airplanes, right? NASA, our National Aeronautics and Space Administration. But some of you might not automatically think about, such as American Airlines or Federal Express. You think of them as a service industry that are providing a specific service, but it requires aerospace engineers to help support that particular industry. And American Airlines, even though what they'll do is buy the aircraft, typically from Boeing or from Airbus, they make a lot of those modifications and changes themselves. And they happen to have the largest maintenance, repair, and overhaul facility for commercial aircraft in the world, located here in Tulsa. We also have the largest maintenance, repair, and overhaul facility in the world for military aircraft in Oklahoma City for Tinker Air Force Base. So those are, tend to be things that we don't initially think about as unique job opportunities for aerospace engineering degrees. So just a couple of local examples. I already mentioned American Airlines and Tinker Air Force Base. And typically, at either one of those, you might work for them directly. You might work for American. You might work for Tinker. Or you might work for one of the many primes that services those companies. So you have a lot of adjacent industries that are part of that aerospace ecosystem that serve those very large employers. Within the Tinker, ecosystem, you'll have companies such as Boeing, Pratt and Whitney, Northrop Grumman, Lockheed Martin, manufacturers of those prime systems and engines and power plants, but also all the components that go on that aircraft. You also have the FAA Mike Monroney Aeronautical Center as another federal example in Oklahoma City. Again, it's the only federal facility of its kind within the U.S., and that encompasses a number of other federal aviation facilities located within that complex. The Civil Aviation Medical Institute, for example, which does a lot of the crash testing to certify the operation of aircraft. The Air Traffic Control Academy, where they train all the air traffic controllers, is also located there. You also have a number of smaller businesses in for the most part, most employees or most students once they graduate will tend to work for a smaller company rather than a larger company. And those are, again, things that you may not be obviously aware of when you graduate. Kratos, located in Oklahoma City. They also are primarily located out of California, but they do a lot of the Firejet manufacturing of that particular vehicle in Oklahoma City. Zivco, which makes all the Red Bull air racers, is located in Guthrie, Oklahoma, employs a number of our students. Frontier Electronic Systems, which is located here in Stillwater, does a lot of work for both NASA and the Air Force on satellites. So they have a number of components that they work on there. So again, this is just a small snapshot instead of examples for some of the different options that you have when you graduate with a degree in aerospace engineering. Now, on the other side, that other track, which is the postgraduate options, you essentially have three options. One is the master's degree, get a master's of science, and you can either get your coursework completed along with a project or a thesis, and maybe take that on to a PhD. But really, the primary difference between undergraduate and graduate is you can think about it in terms of breadth and depth. For your undergraduate degree, you're primarily focused on breadth. You have a number of different courses that you're taking, and they're fairly broad, and so they cover a fairly large spectrum. Because again, you don't know what you're going to be doing when you graduate, so you'll be taking things, across a pretty wide range from aerodynamics to structures to propulsion. At the graduate level, you specialize and you say, hey, I'm going to focus, for example, on aerodynamics. That's what really interests me. I want to learn more about that, and I really want to have a career focused within the specific discipline. And that's why you go to graduate school, so that way you can start to work on that depth. So that way you go much deeper into those particular topics. And you'll typically, instead of taking 4 or 5 courses a semester, you'll take 2 or 3 courses a semester, but they're at a much deeper level. Now, if you're really interested in deep level research, such as working at a government research lab, someplace like Sandia National Laboratories or Los Alamos or Draper Labs, that's where you'd go and get your PhD, and that's the highest degree that you can get, and really focused on that specialty research, and that's where you become an expert in that particular field. Again, you would pick a specific discipline that you would build upon, composites, for example, and so that way you'd focus on a very specific problem in that area. And the goal of the PhD is to be able to solve that problem, learn how to solve those problems, and take those out and be an industry leader within that particular subspecialty. Now, there are other options, such as the Masters of Engineering, which is a non-research component based program, which is really aimed at working professionals. Now, I did mention those other opportunities, such as MBA, getting a law degree and stuff. Those tend to be pretty rare. That is an option, but if that's something that interests you, let me know, and I can certainly put you in touch with the right people. Now, what to choose then, right? Should you go straight in the workforce, or should you think about graduate or professional school? It depends, right? It's really up to you at the end of the day. You just have to weigh the pros and cons. And things may change, right? Like I mentioned earlier, I had originally planned on not going to graduate school, and then I figured out no, that actually really aligned with what I wanted to do with my career, and so I ended up shifting that when I was a senior. Once I figured out what I really enjoyed in aerospace engineering. So it's just something that you have to think about and figure out, which is best for your long-term career options. You can do a lot of great stuff, graduating with your bachelor's degree, but getting a master's or PhD also opens up a lot of different kinds of doors and different kinds of opportunities. Now, something I do want to mention, right? Primarily we're focused in the aerospace engineering curriculum, and really the engineering curriculum as a whole, as these specialty disciplines, right? That, you have to learn about fluid mechanics, so that way you can learn about aerodynamics, so that way you can learn about stability and control, right? And we build upon these all the way up to a vehicle design, for example. So these are those specializations, these technical skills, which are really required, for you to be proficient in that particular field. However, intertwined in all these are what the things that the employers are really looking for, right? And what I mean by really looking for, they know that if you're going to graduate with that bachelor's degree, that you're going to have some acumen in these technical skills. You've gone through the classes, you know how to work the math and do the problems, right? What they don't know is how good your soft skills are, right? Your team building. How well do you work on a team? Because at the end of the day, all engineering is teamwork, right? You don't work in isolation or in a vacuum. So you have to be able to work with other people, whether you're trying to solve a problem alone and you're handing that problem off to a colleague or a customer, or whether you're working in a really large, diverse team. So having that capability to take leadership roles, to be able to communicate effectively, is really, really important, right? And so you want to be able to build up those skills as well. And we build that into the curriculum, which is why we have all these team-based projects, right, that you have to endure as part of your undergraduate curriculum. Getting involved in extracurricular activities, particularly things such as professional societies, volunteer groups, these are really important, not only for your development, but also to show on your resume, because these are the things that employers do look for, that ability to communicate effectively with that potential customer that you're going to have. Now, what about your dream job, right? You may have something set on where you want to work at. How do you land that particular opportunity? The best way to do that is to get experience at the undergraduate level, right? Because that's what they're looking for on that resume. The guaranteed best way to get a job at a particular company is to have an internship there, right? So if you can get that internship, that's a direct pathway to full employment at that particular employer. So that's the number one sure way to figure out. First off, is that where you want to work at? It goes both ways. They're looking at you as a potential employer. You're looking at them as a potential sorry, they're looking at you as a potential employee. You're looking at them as a potential employer. But in addition, you want to be able to build your resume with those soft skills that I mentioned previously, that those leadership and team building capabilities, to demonstrate that you can lead a team and work on a team, as well as developing your technical experience, that you're able to use the things that you learned in the classroom outside of the classroom on real world design projects. And you can do that either within the university through undergraduate design and research projects, or outside the university working with different companies. But keep in mind, there are also many career options that you aren't aware of yet, right? Your dream job you think you may want may not be the dream job you want a year from now, 5 years from now, or 10 years from now. So look at all the different paths. You have options that you can explore. So the mantra I always like to use is
Let's take it
explore the
again.
space.
And Gene,
Yeah,
really explore the studio space this time.
you got it, Bruce.
I mean, really,
Yeah,
explore the space.
okay.
Okay, so explore that space. Okay. So some random further info. First off, use OSU Career Services to do your resume check, look at job opportunities, to go through mock interview processes, to get involved in the career events that we have on campus. We have some of the best career fairs, throughout the country, really. Participate in those professional societies. If you're an aerospace engineering major, you should be a member of AIAA and get involved in AIAA. And if you don't, get involved in some other student organization. Really whatever floats your boat. There's some other good things you can look at here. NASA and Sandia, which I both mentioned previously, have some good examples, for what different engineering opportunities are out there, really from a large perspective. I would like to plug one final thing. We have a visitor from NASA JPL here on Sunday that will be presenting his work on the Mars exploration systems that NASA JPL has built, designed, working in a really large team of engineers and scientists and successfully send to explore the red planet. So it is a unique opportunity to go and hear from an engineer firsthand about what their experience is, particularly in the aerospace industry. So with that, I'll take any questions if there are any.
Dr. Jacob,
Yes.
when you were talking about best way to get like that dream job, you're talking about research and about graduate. Is that after your bachelor's degree or is that during?
That's during. So you, as an undergraduate student, look at some of those other design opportunities to get involved with, and that could be. I'll give you the ones that I'm most familiar with, that I'm involved with. We have teams of students that are involved in something called Microgravity University, which is an undergraduate design challenge put out by NASA. And so those teams get together, they look at the challenge that NASA has put out, which is a real world problem that NASA has, and says, hey, we need something that does this, right? And we don't have enough time to spend on this, so we're hoping that you guys can, find a solution for us. That's an example, right, where you have a group of undergraduate students coming together as a team, or getting involved in an undergraduate research project. We have another number of projects that we work with NASA with on different research opportunities, so students can come in and volunteer their time helping out with that, and that allows you to start building up your resume. Rather than working kind of those odd jobs, which may not be engineering related, to have something really engineering focused on your resume.
For those research, do we just talk directly to the professor or is there like
Yes.
some sort of space we go to?
Nope, you can just reach out directly to the professor. Best way to go is look at the website, and it doesn't have to be within MAE. There are other opportunities outside mechanical and aerospace engineering
Hmm.
that you can look at. Look at the web pages. Talk to your fellow students about the stuff that they're doing, and just email them directly.
Awesome, thank you.
All right. If there are no other questions, going once, going twice. Sold. All right. If you do have any other questions that come up afterwards, feel free to reach out. My email address is jdjacob@okstate.edu.